Hello. Testing. 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 Check. Mm, Audio. Testing mic. Testing mic. I don't like that. Um, test test. I don't like this. No. Alright. I'll figure speaker this. Mm, that's where that was. Test test test. Does that sound better? What? Is that? Mm, test 1 2. Test 1 2. Mm, um. Let's see. This better here. Alright. Boost this. Test 1 2. Test 1 2. Bad. Bad. I'm gonna get feedback. Hold on 1 second. Let's test that now. Oh, that's so much better. Okay. All right. So this cable that we tried is a bad idea. We got something that works. Let's stick to what works. It's worth trying it out. Let's see if it works. Do, 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 do. 1 second. Alrighty then. I think we got something up and running. Okay. Welcome, welcome, welcome. So maybe I should change that. I don't like that the YouTube stream did not change its name. That's a bit loud, huh? How's that? Drop it even down to there. Oh, I need to. Hello? Like this. A little bit more. Okay. 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 So, hold on. Let's see if we can change the stream title on the YouTube channel. Alright, can I in this video? No, even when I'm like that, I can't. Okay, well, it is what it is, what it is, what it is. So, welcome, welcome, welcome. For those of you who are interested in doing a little math, we're not going to go too deep into it today. But I wanted the chance to do something, little something. And I needed to test out that, what's the thing? Hergle Blurgle. The other cable, mic input methodology and see if it worked. And long story short, no, it didn't. But whatever, it was just a cheap cable. So we're sticking to what works. Yeah, excellent. Let's see here. What am I trying to open up? What would you say you do here? My headphones are really loud right now. Okay, oh, it pops right up. What do you know? It's a little better. I still have to fix the why is it maxing out at 720p? All right, it's time to go exploring. This over here. Let's let's see. Okay, sure. Let's look for OBS Twitch stream resolution max 720p. Yeah. Okay. Which one are you streaming? 720, midway streaming 1080. Oh, okay. Let's look then at. Right, this I'm gonna turn off for a second. Let's log into Twitch and take a look at oops. Again with the troubleshooting. That's pretty much all we do here. The purpose of this stream is now to troubleshoot streaming on Twitch. It's called an Ouroboros. Not Ouroboros. Ouroboros. The snake eating its own tail, whatever it's called. Anyway, let's see here. Stream Manager. Sorry. Okay, got it. So, all right. So it says we have no channel changes. Permissions. Permissions. No. Party events. Okay, that's fine. I'm trying to find my chat activity feed. Okay, so that's interestingly saying 1080p source. So if I go over to the actual channel and take a look at it, go to my channel, look at the peak. Oh, it's now able to go up to 1080. Okay, so I don't know why it took that long for it to settle down, but it looks like it's able to go to 1080p. Beautiful. Okay. So it just took a little bit of time to get there. Yeah, outstanding. Let's go ahead and take a look at our uncensored comment here. Right. So if we look at this and then we open, we want to open our notes here in Kalman filtering. Let's see. Okay, we're moving over our notes in Kalman filtering. Where are all our notes that we wrote here? Okay, here we go. We are logged into the correct one. Oops, this ribbon. Excellent. All right. See if we can't change this to I think we might need to add source window capture, existing OneNote. Where did it go? Oh, there it is. There it is. Jump scare. All right. So we are not operating with the ability to actually mark notes on here right now, but we can, of course, at least look at the notes that we have. God, this is for some reason the mic is like super loud right now. I'm gonna drop that mic volume down just a tad. I didn't really do anything to it, but for some reason it boosted the mic volume. I don't know. Um, so if this mic volume is getting to you, just please let me know. All right, we were down here and we were looking at um, excuse me. Right, we had said that we wanted to do everything as uh, the the data point is an entire days of data, so that way you can get a real um, uh, what's it called, variance in your data. Okay. So we're gonna start by just finding all this stuff. Um, we're gonna say that okay. We've already got those two loaded, and now we're gonna go through and say got all that. And we've got all that. Okay, so everything is sort of loaded up. We should have everything um, in our variables there, and we need to go to P naught, which is, if I remember correctly, Jesus, still seems really loud. I think it's my not gonna lie, I think it's actually my headphones being really loud, not the stream audio. So if the stream audio is really soft for some reason, please let me know. Actually, what I'm gonna do is okay, we're gonna chat that out. Oh, you kidding? Sorry, 1 second here. Do 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 la da 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 bow bow ba da da ba ba ba. You ain't never had a friend like me. Sorry. uh, there we go. To these. Darn it. Okay. Uh, we need to just go ahead and pin this guy. There we go. And now we need to do a similar pin on the YouTube side. So if we take this and we spam it over here. We send that, and then we this guy. Cool. There we go. So now, if anyone runs in, they can let me know if the audio seems good, bad, or in between. Cool. Just it sounds so loud to me, and I'm not sure why. Anyway, regardless, let's get back to work. So we are looking for P naught, and P naught is okay. So first, let's talk. One sec. First, let's talk x hat naught, and x hat naught is the mean of these things, right? Because it's the expectation value of that. And now, so p hat naught should be how do you do the per? Right. So if I did x hat is let's see here, hat x, hat x, hat x, hat x, hat x, hat x. Hat x naught is a list. I don't think you can transpose a list, so let's do it as an array, right? Um, so now if we do so x naught is but so if we do x naught minus hat x naught, let's just start this way, right? We do that times np dot transpose of that secondary sequence. The requested array has an inhomogeneous shape after one dimension. Really? Oh, you know why? X naught isn't array. That would probably help. Oh, what? X naught. Gimme. Gimme. What is X naught? These. So X naught is a list. Oh, wait a minute. Why are these lengths different? Let's see here. So X naught should be first day vector. 144 makes sense. First day SNR. Yep. A velocity vector. Oh, it's because I'm manually doing. That makes sense, right? Because I'm manually doing velocity that way. So if we did like that, right? So theoretically, velocity is kind of infinite, going from 0 to the first point in the street in the array. But let's see how. Let's go over to here. So if we search Python instantaneous derivative of array of pi array. Okay, I want to get you right. So functions have verbs. That's also values for each kind of function. We did gradient is, let's see, 5, 6, 7. Okay, 2, 3, 4, 5, 6, 7. Okay, so it looks like gradient works. Okay. So if we do, rather than doing this, right? Let's, rather than being silly, let's use this. np.gradient first day vector time. Right, so if we do this, hold on, one thing I want to do, I want to check. Let's see what the length of that array is when I do the gradient, if it's the same. 144, beautiful. Okay. Don't need any of this shenanigans. Right, what we should have done to begin with, and now wait, now we're changing it to SNR, and there we go. Let's try that again. Right. Now, and now we are 144, what's 143? Yes, another velocity vector. First day, hold on. First day SNR velocity vector. Ay, all right. Let's see what happens now. Okay. Now when we go through this, we go through all this. Okay. So I should show you what I'm also doing here in the oops. In the over to here. Oops. There we go. I can at least see what's going on this side of the screen as well, which is a little helpful. There we go. I can make myself a little bit smaller here. So I'm hiding. I'm hiding. Okay, there we go. Should be taking up most of the screen now. So the troubleshooting we're doing now is we're trying to figure out. Oops, that's not one. Okay, so let's see. Oh, right. That, and now we look at this, and now let's look at what X naught looks at. Looks like X naught looks like a list. Why is that? What the hell? Something went wrong. Voop voop. What's voop vooping? Okay. Um, why did that end up as? Why did that not reset? Is anything else two-dimensional? Anything else we're concerned with this stuff? We're not concerned with this stuff. What are we looking for? First, so under F. So first day vector is 144. First day. Okay. Okay. First day velocity vector is uh, what? Why are we doing it that way? Okay, so first day, right? So first day velocity vector should be that. First day SNR velocity vector. Okay, so those are zeroed. Correct. First day vector is a single vector of 144. First day SNR is a single vector of 144. Um, oh, I'm doing the stupid thing in a loop. Why am I doing the stupid thing? I found the problem. All right, now when we do this, and we do this, and we do this, now X naught is a healthy. Okay, those are rows and those are columns. I don't want that. I think they should all be column vectors, right? Uh, so this ends up being a row vector. This is a if I go to first day, vector. Those are column vectors. And then I go to first a velocity vector, a list with a single array. So why do we even do this? We don't need this, right? Because that just equals that. We're not doing the thing anymore. We just do that. Now, first day velocity vector is 100. There we go. Now we're cooking with gas. Okay. Now, all this to just try and. There we go. All right. All right. So if we do this now, will that work? Yes. And now hat x. Will it do this? No, of course it won't. Well, it doesn't make any sense. Why would it do that? Okay, let's take a look back at our notes. Okay, so excuse me. X hat naught is the expectation value of x naught, right? Hmm. Yeah, that does make sense. Um, so if we're saying this is x naught, then one sec. Um, let's see. You want a 5D array probability? No. That's not what we're looking for. Let's see. Yeah, so the expectation value of a vector is just going to be, all right. Okay, sorry, we're just doing a little research in the background as we're trying to things to write. So the problem that's going on is x hat is necessarily the expectation value of x naught, right? But the expectation value is typically of, so normally the expectation value would be the number multiplied by the probability of that number occurring, right? Uh, let's see. Uh, um, sorry for the quiet. We're just looking some stuff up. So, oh, we should be able to potentially do, what's this? That works. Oh, what? Oh, okay. What happens if we just do There's a built-in covariance. Oh, I knew that. I freaking knew that. X. No, not basis equals false. What? Bias, not basis. What if I just do this? What's the size of that? 4 by 4. That's what it should be. Is it just the covariance? Is P not just the covariance matrix? Am I just a moron? It is just the covariance. Why am I going through all this manually? Right. So let's just make sure that we're doing this correctly. All right. So this should come out the same. So if we do right. Um, equals times transpose that. I press 4. Um, mm, oh, that's why. Okay. So, things I've learned. Um, B is matrix multiplication A and B. A times B is phi, or is element Y is. Okay. And now sorry, temp over B and minus 1, right, to get the covariance. 3 equals np dot cove x naught. No, they're off by a fair bit. Why? X100. Right, so oh, hold on. Hold on. That's it. Okay. Okay. So it is the same. It is the same because it's n minus 1, n being 144. Okay. So we can just say, right, because x not yet an array. Well, at right here. Is this over 143? So, but we're gonna do not. Right. Okay. So there we go. 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 I think it was probably kind of cheating that we eventually found the covariance commands that I totally forgot was a part of NumPy. Awesome. 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 Awesome sauce. Okay. What am I doing right now? Right. Right. So now with that in hand, right, we have to look up this again. Okay, so we've got all of our initial states. So now we've got to start executing. Okay, now we've got to start Q. So these are all right. All right, let's say we've got those. So executing the filter recursively. Okay, so let's start with this. All right, we went through and looked this up somewhere. this decomposition and wrote it down how to do it. It tells you this decomposition finds square root of P. The elements of P are PII is PII minus the sum from K equals 1 to I minus 1 of the square root of the ikth element squared. Okay. Okay. For j is less than PIJ looks like you calculate these first and then that. Okay. First things first, let's not repeat mistakes. I understand how that's put together, but let's not repeat mistakes. Let's see if there's a lower Cholesky decomposition built into Python. Where are we? Cholesky decomposition. Oh, cool. What do you know? Okay, anyway, let's sorry, reading articles, and that's very boring to do on stream. So let's go over here and let's okay. So that's that. We're gonna have to put this into a recursion in a moment, but for now, let's at least do this. Okay. Trying to figure out how I'm gonna submit to my writing group. I have so much other stuff to try to do. Okay. So square root of p is that, right? And so now sigma points no minute like the last. All right. So now we need to calculate the sigma points. Cool. So chi equals. Okay, so this is before we're doing this recursively. So we're still kind of doing the setup here, right? And then not chi naught, right? We're saying k minus 1 is 0. Um, all right. So calculate the sigma points are okay. Hat x naught at x naught less e dot square root of L plus lambda. What do I call it? Lambda underscore times root p naught. Okay, so that's the second one. And now the third one is that, but a minus. Okay, so there's chi naught. Good. Okay, so now we have all of our setup. So now we have to do for kk equals, or for, I'm sorry, k equals 1 equals in range 1 comma it's the number of days, so p dash shape dive complete 0 31 0 and let's just test. I think I have to add a 1 to that. Because we need to start at 2, right? So it's k minus 1 needs to be the first day, so I'm sorry. 2 plus 1. That should get us there. Beautiful. Okay, so k is going to start at 2. Right. So we're saying this is all technically k1, right? So, okay. So k minus 1 is going to be 1. So now, we're going to start here. So, if k equals 2, right? So the first go round, it's going to, excuse me, it's going to be using all the knots, right? F is a loss function. What's decent? I hold on hard for loss. All right, how did they do that before? Right, I remember this being right. This was an issue that we had before where we had to figure out what F was, and we had wanted to say right. So here. Um, do I have? Am I defining F here? Let's see the other example. Okay, falling body example. Right. And the state is that, and the state equation becomes that, right? Okay. Um, Measurement equations. Nice case. Uh, Clean time series is first modeled as a nonlinear regression where the model f parameterized by w was approximated by training of feedforward network. Okay. So I wonder. So you know what we could do? could use our hat function approximation. Okay. Let me look up something here. Oh, shit. Um, okay, so okay. Yeah, so we need to figure out um sorry, I'm just looking something up really fast in terms of how to, what we're gonna apply for f. So one idea is to just apply uh the value plus the velocity. No, that's not right. Um, sure. So the measurement model would be That's what we want. Okay. So if we're okay. It's just day-to-day evolution. Okay, so it's literally just um okay. So okay, so what we can do is as follows. We're gonna say this. Ah, sorry. Please try f of x uh, k plus 1 equals f of x. I'm sorry, equals x k plus w k. Right, so it's literally just itself plus the error, right? The w, excuse me, the w term, and the w term uh, is do we have a so the w term is the noise of talk about w here or w. So w is w is the process knowledge of the covariance. Q, sure. So x equals, right, this x naught. Uh, First, Q is that. So that means um, um, first off, it should be Q naught, and this is NP dot covariance of this, right? This means, hold on, W naught equals this. Oh no, it's not actually the covariance, is it? W naught equals that. Right, and then Q naught is no, it's the covariance of W naught. Right? Shouldn't that be a W times W at wait. Let's see. Wait, why did that work then? That's a 4x4. Oops. That's a what? Hold on. X naught is okay. W naught is 4 and 144 each. Or 144. So why? This is so bizarre, right? Because we're doing the same operation. Oh no, we're not. Oh yeah, we are. Right. All right. Let's remove this array thing. Hold on one sec. So remove that. Right. W naught is the same as X naught, right? No, it's not. No, it's not. Because not actually an array of those things, right? Because it's just a vector. See, these are just numbers. So, W naught NP dot transpose Right, that makes sense. Because each is a 1 by. So clearly it's not what W is going to be, because W's got to be the error, but it's going to be a vector though, right? So it just says here, like W is the process noise. Right? It just says these are the noise things. Okay. XK plus V. Parameterize was approximates the training field error after the convergence was taken to be the process noise variance, so residual error. Oh, okay. I have an idea. Okay. Is that what I was saying here? Visual state excess day, so return. So um and okay. That's just a Gaussian distribution. Okay, we can just do a Gaussian distribution where R is 144 by 144. Okay. So we actually made some progress here. I am gonna run off and run away. We were successful in the things we were trying to do. Mainly testing out the audio. It seems to work. I think the mic is working really well now. And we managed to get a little further in our work here. So that's good. Yeah. So thank you for joining me today. We're gonna stop here, I think, and next time we go, we'll do something different. Maybe we'll do another story. I think I'd like to read another story. So and next stream I'll announce also on my Discord. So we'll have a little bit more interest going on there. All right. You guys have a great evening, and I'll talk to you later.